All right, guys, this is chapter 4, section 1. This is day 2 of it, and I know this first slides might look very similar to day 1, but this really is day 2, so just bear with us for a couple minutes and we'll get to the day 2 part. First thing, before we begin any of this, you have to know the basics, and the basics are, do you know what the graph of a sine looks like? Do you know what the graph of a cosine looks like? And so this part truly is a review. We've done this before, so if you've got this part, just kind of listen, or I guess you could fast forward also. We label our x-axis, remember, pi halves, pi, 3 pi halves, 2 pi. Our y-axis went up to 1, down to -1. We've got this chart. We got this from our unit circle. We had the point 0, 0, pi halves 1, pi 0, 3 pi halves -1, and 2 pi 0. And we connected this with a nice smooth curve and said this is a graph of our sine wave. You must know these 4 key points. And again, you can argue, wait, you just circled 5 things. True, I did, but 2 pi and 0 are the same thing. So you need to know those 4 key points for a sine graph. You need to know a sine graph looks like this. And again, if you remember, we showed this already. I put this now in chart form. This is really going to be a nice way to work with this. So we've got our key points, 0, pi halves, pi, 3 pi halves, 2 pi, and then these key values, 0, 1, 0, -1, 0. We said you can also think about the unit circle. Remember it that way. But you want to know what a sine graph looks like. So this is our sine graph. Sine of x, sine of theta. Doesn't really matter what variable you're putting in there. Second thing that's review is our, oops, did I get ahead of myself there? I think I did. Second thing that's review is our cosine graph. We had the same approach. We had 0, pi halves, pi, 3 pi halves, 2 pi. Started at 1, went down to -1. It's kind of neat to see all these connections, things we had at the beginning of the year. How big does a sine or cosine graph get? We plotted our points, 1, 0, -1, 0, 1. You could be tempted to make just a nice V there. That sort of looks like a V. But if you plot more points, you'll realize it truly is rounded, and that's our cosine graph. So those are the 2 non-negotiables, the 2 essentials. You just need to know what they look like. And again, here's our cosine graph with a few more points plotted. So it's the cosine of theta, or the cosine of x, what you want to call it. And then again, this chart, which will be invaluable. And when we do more graphs, you'll probably want to start with this chart and have your key values, from both sides of that, and know what those are. Okay, today I want to add in something new. We talked about the amplitude yesterday in the previous lesson, and today we're going to talk about the period for a function. And the period is the time it takes for a function to repeat. So we know these functions, a sine graph goes, up and down, it oscillates forever in both directions. And the period is, well, how long does it take to make one oscillation? So that's what the period is. The definition of period, the time it takes for a periodic function to repeat, or for one cycle of it. And the normal period for a sine or cosine graph, is 2 pi. Once we got to 2 pi, those graphs started over. Our sine graph went from 0 to 2 pi, and then it started over. Same thing for a cosine graph. When we went to 2 pi, it went up, it came like that, and it started over again. So our normal period is 2 pi. The question is going to be, what happens when you put in a little number inside the trig function? Not to be confused with the number outside. We did that yesterday. Outside was the amplitude. It made it go up or down. So the question today is, what happens when you put a number in the inside? And easiest is just pull our calculator and graph these and see what happens. Kind of take the suspense out of this. And then we'll, once we've seen a few times what happens, we can do these on our own. So let's try here. Sine of 2x. Big hint, it's going to affect the period. Maybe a nice window. Let's go from 0 to 2 pi. That's normally the time it takes for one cycle. And our y's here, maybe count here by pi halves or something like that. Those are our scale. And our y min and y max, let's just go from -2 to 2. We know 1 to 1 is enough, but just to give it a little room on the graph. All right, let's see what this is. What are we graphing again? We're graphing the sine of 2x. Let's see what happens when we do that in our graph. Looks like a sine graph. But look at this. When you put a 2 on the inside, let me make that just a little bit smaller so it fits without covering things up. When you put a 2 on the inside, instead of 1 cycle, you get, look at that one, 2 cycles. So what does it do to the period, the time it takes to repeat? Well, it was 2 pi. Look at that, guys. It cuts the period in half. So you take your normal period, you divide it by 2, because now we get a full cycle of our sine graph in pi radians. So the 2 on the inside makes it occur twice as fast, or it cuts your period in half. So twice as fast would mean the same thing as cutting the period in half. Okay, same things are going to happen with the cosine graph. Let's try this one with a half in here. And hopefully you're guessing well. It's going to cut the period. It's going to occur half as many, or dividing by a half, it's going to double the period. Let's take a look and see. Let's go cosine. And we've got 1/2 x, so it's going to occur half as frequently. 1/2 x. Let's see what this looks like when we hit graph. And we have the beginning of a cosine graph. Put that over here, shrink it down a little bit. But we only really get half the cosine graph. We don't get the other half of it where it comes back up. So the normal period was 2 pi. How do you divide by a half? Multiply by the reciprocal. So the normal period now is going to be 4 pi until you see that whole graph. So 2 pi wasn't enough anymore. It's going only half as fast, and so it doubles the period. So divided by a half is like multiplying by 2. These next two, I think you can guess. Cosine of 5x. If not, certainly watch and see. Cosine of 5x, are you thinking that occurs 5 times more frequently? Look and see. 1, 2, 3, 4. Look at that. Hopefully that was your guess. Oops, let me put that over here somewhere. And then sine of 4x. Hopefully now you're getting to say, okay, I got this. Sine, oops, that was in the right spot. 4x. Think you get 4 of those? There's 1, 2, 3. Look at that, you got 4 of them. No big surprise. Okay, so how do we say this, abstractly, or how do we say this in general? Well, a nice way to say this is the normal period was 2 pi. So when you put a number on the inside, we call that b on the inside, then your new period is going to be 2 pi divided by that b. So whatever that b is going to make it go half as much, twice as much, depending on what the b is. Okay, so let's try a couple of these and see what we get. Find the period for the following, then graph, and they want us to graph 1 cycle. This will take some practice here. Graph 1 cycle of the graph. Sine of 4x, let's see, I see that 4 in there. That's kind of my key. I know the normal period is 2 pi. I'm going to now divide by 4. I look at the 2/4, I know I can reduce that. So now I'm going to get a full sine graph every pi halves. Okay, so now I want to sketch this out. Well, we knew before we would sketch down here pi halves, pi, 3 pi halves, and 2 pi. But we know now with this 4, our graph is occurring 4 times more frequently. So the 2 pi was divided by 4. And as a matter of fact, guys, everything is divided by 4. And that might be a little tricky at first. How do you divide by 4? And if you're good with fractions, don't worry about it. If you're not so good with fractions, let's take pi halves. How do I divide by 4? Easiest is multiply by the reciprocal, 1/4. And look, I get pi eighths. And certainly ask this if this is not making sense, the fraction part of it. Tomorrow I'll be happy to help it. Pi fourths, I think that was a little clear. That's pi fourths. 3 pi halves. I'll multiply by the reciprocal, 1/4. That becomes 3 pi eighths. And the 2 pi, we've done that before, it becomes pi halves. So it turns out when we sketch this graph, when we label the x-axis, we don't have our pi halves pi, 3 pi halves, 2 pi. It's going 4 times as fast, So this is labeled pi halves. Remember the pi halves divided by 4? That's now labeled pi 8. So it's going to be very important to label your graphs, because all these graphs look the same. You have to look very carefully at the x-axis to see what the difference is. Still goes up to 1. Still goes down to -1. That part hasn't changed. And remember, a sine graph goes 0, 1, 0, -1, 0. Sketch it with a nice smooth curve. And it looks identical. We've just labeled the x-axis differently so you can see, wow, I'm not waiting 2 pi to get this anymore. It's going 4 times faster. I get this in pi halves. Okay, very, very similar for this cosine one. We can take our key points, which were the pi halves. We can take the pi, the 3 pi halves, and the 2 pi. We're going to divide all these, just like before we divided by 4 over here. We're going to divide by 1/3. How do you divide by 1/3? That's the same as multiplying by 3. So this is only going 1/3 as fast. So I have to take all these things times 3. So I get 3 pi halves. I get 3 pi. Oh my goodness. 9 pi halves. And take this times 3. And it looks like 6 pi. So when I label this graph, it's going 1/3 as fast. I'm not going to get this in 2 pi. It's going to take me 6 pi to get this graph. And down here is my 3 pi halves, and my 3 pi, and my 9 pi halves. Doesn't change how much up and down it goes. Here's 1. Here's -1. Cosine graph, remember, starts up here at 1 to 0 to -1 to 0 to 1. And I sketch this with a nice smooth curve. Looks good to me, except down here I can see, wait a minute, this is a different graph. This is not my regular cosine graph. This is the cosine, look at that, guys, of 1/3 x. Okay, that is our main idea today. What we could do is we combine this. I'd like to show you maybe 1 or 2 of these. If we don't have time for too many more of these, we'll see if we can get 1 in. You can combine this with yesterday's lesson. You can do an amplitude and a period. And so let's take a look. They're all about the same. Let's do the first one. And if I was doing any of these problems over here, I think I would really start with a chart. Okay, and let's do the period because that was fresh on our mind. We've got this 2 in here. We know the sine graph is occurring twice as fast. We know all of our x-coordinates, all our points here, are going to get divided by 2. So let's divide those by 2 right now here in this chart. I think is a nice way to do it. And 0 divided by 2, no big deal. That's still 0. Pi halves divided by 2, or times the reciprocal, that becomes now pi fourths. Pi divided by 2 is pi halves. 3 pi halves divided by 2, that's times the reciprocal. That becomes 3 pi fourths. And 2 pi divided by 2, or times the reciprocal. Look at that, it's 2 pi over 2, or just pi. So that was our first part. That was the period. Makes it go twice as fast. Okay, remember yesterday? Remember the amplitude? I've got a 4 out here. What is that 4 going to do? It affects how much up and down it goes. But wait a minute, up and down, that's the y-coordinate. So I come over here. Here was x. Here is y. I come over to my y-coordinates, and all of those are going to get multiplied by 4. This is what we did yesterday. So we went up 4 times as high, down 4 times as low. So I take 0 times 4, still 0. 1 times 4 is 4. This is, oops, I almost put a 4 there, didn't I? Still 0. That's a -4. And still a 0. So I can sketch my new graph. And again, I knew, maybe you're doing parts of this in your head, I knew it was going twice as fast. I only need to wait till pi to get this whole graph. Here's my pi halves. Here's my pi fourths. Here's my 3 pi fourths. And instead of going up to 1, it goes all the way up to 4, goes all the way down to -4. And I'll plot these points and I will have a new sine graph. Let's see what it looks like. 0, 0, hasn't changed. Pi fourths goes all the way up to 4. And I've got my pi halves, my 3 pi fourths, and my pi. And again, without the labels, I would agree every graph looks the same. But with the labels, both the y-axis now labeled, showing, look, the amplitude is 4, and the x-axis labeled, saying, look, this is going twice as fast as a normal sine graph. I can tell that this is a different graph than my other sine graphs. I'd like to leave it here. I think that's enough. And I think, honestly, the best thing we can do tomorrow is just have you guys work on this. There's got to be questions. Some of you will not have questions. Other people will have questions on the fractions. And rather than do 3 more examples that will have the same questions to them, I think this is a good spot to stop. So, thanks for watching the video. Maybe I'll surprise you with the quiz tomorrow. Actually, it won't be a surprise because I just told you. I hope you guys have a great afternoon.